Hello everyone, and welcome to this presentation on ECMAScript internationalization. My name is Shane Carr, and I work at Google in the ITN engineering team, and I'll also be joined later by Ujjwal Sharma from Igalia. So, first question is, what is ECMAScript? ECMAScript is a standard by ECMA International, which is a body that facilitates the timely creation of a wide range of global technology standards. And ECMAScript is the scripting language specification standardized by ECMA International. Now, you all probably know ECMAScript by its street name called JavaScript, which is the best known implementation of ECMAScript since the standard was first published. So in ECMA International, we work on the standard for ECMAScript, which is in turn implemented by JavaScript. So for all intensive purposes in this presentation, when I say ECMAScript, you can think of it as being JavaScript. So who uses ECMAScript? Well, there's a number of types of things that use ECMAScript. One of them is almost all web applications use ECMAScript. Mobile phones use ECMAScript like PhoneGap and React Native. There's lots of mobile application frameworks. Increasingly, servers are using ECMAScript in the form of Node.js. Internet of Things devices are using ECMAScript. There's a whole subcommittee in ECMA International working on standardizing ECMAScript for IoT devices. Startups use ECMAScript. Enterprises use ECMAScript. Students use ECMAScript. It's one of their first languages that many students learn these days. So it has a very, very broad impact, ECMAScript. Here's some statistics on ECMAScript usage across the industry. This is from a Stack Overflow survey in 2019 that shows that JavaScript is used by a large percentage of developers and is used overall by the highest percentage of developers over the past year. So more developers have used JavaScript over the past year than any other programming language. Now on this slide, I also want to point out that Java and JavaScript are not the same thing. So just to make sure that we don't get confused about that, I'm talking about JavaScript, not Java, in this presentation. This is just another graph to sort of show the popularity of JavaScript. This is GitHub pull requests. If you look at the number of pull requests on GitHub and look at the programming languages that they're primarily written in, this is what we see. JavaScript has the highest percentage. Almost 20% of pull requests on GitHub are written in JavaScript. The next is Python at about 15 or 16%. So based on these two slides, we can see that that JavaScript is a very widely used language. That's why internationalization is so important in ECMAScript in particular, because with awesome I18N tools in ECMAScript, we can raise the bar for localization across the whole industry. By having ECMAScript as the standard for internationalization, and that's why we care so much about internationalization in ECMAScript. Okay, so now I'm going to dive in a little bit more into exactly how I18N in ECMAScript works. So what I'm going to be talking about today is specifically built-in JavaScript functions that produce localized output. There's lots of third-party libraries that do internationalization in JavaScript that you can link into your apps, and many of them are very, very good. Many of the people at this conference have written and presented about them in the past. But this presentation specifically is about are the built-in JavaScript functions. The ECMA 402 task group, which I chair, sets the standard for this subset of ECMAScript. So we provide a programmer tool set that conforms to Unicode CLDR standards and promotes best practices and eliminates the need to carry an extra I18N library. Okay, so let me talk a little bit about how this all works. So first, on the bottom of the I18N stack in the web is Unicode. Unicode is the standards body for I18N. They set the standards for how I18N works in computers. Above Unicode sits CLDR, the Common Locale Database Repository, which is a locale database that contains data that powers the standards that are specified by Unicode. Above CLDR sits ICU, which is a C++ code base to process locale data from CLDR. Above ICU sits the browser engine. A browser engine could be something like V8 in Chrome or SpiderMonkey in Firefox or JavaScript's core in Safari that uses ICU to implement JavaScript. All major browser engines do use ICU to implement JavaScript, although the 402 standard does not require that to be the case. On top of the browser engine sits ECMA 402, which is what our standards body is in charge of. We define a programming interface that exposes constructs that you can use in the language that allow you to perform internationalization. And the browser engine implements that interface. And then finally, on the very top of the stack is your application. So your application calls the ECMA 402 interface. The ECMA 402 interface is implemented by the browser engine, which uses ICU, which depends on CLDR data, which is defined by the Unicode standard. So this is how the I8N stack on the web works. So why would you use I8N libraries? Why are they important? This here is a screenshot of the Despacito video on YouTube, which has over 6 billion views. It's quickly approaching 7 billion views. And it has dates, it has compact decimals, 3 million upvotes at the time the screenshot was taken. And this screen shows many, many different types of features. We need to do number formatting, we need to do plural rule selection, we need to do date formatting. Like I said, we need to do compact decimal formatting, compact notation. So there's many, many things we need to do, even just in this one little screenshot. And that's what internationalization is here for. So sometimes some of these strings you can get translated in your translation pipeline. But a lot of the times you actually have to call into an I8N library to perform basically localization on demand, and that's what we're here for. That's what we provide. So next I'm going to hand it over to Ujwal to talk about some of the things you can do today in ECMA 402.
Hi everyone. So now that that's over with, let's talk about the fun parts. Let's talk about the ECMA 402 features that are available to developers today. And let's start off with locale parsing. Now you all know that we can represent locales using Unicode locale identifiers like this one. But we provide a convenience constructor called Intl.Locale that allows you to mix and match locales, especially using the JavaScript object format. So like here, I provided the calendar Gregory, but I can provide more options like a script or a region. And once I've created that object, I can query that object to get the language, the R cycle, or the calendar that it picked up from different places, and I can also pass it around different constructors using the toString method. So it gives me, as you notice here, the full Unicode string for this locale. Moving on to number and currency formatting, we can create a number format object. So here I have a number format object using English as spoken in the US, and I can format a number using it, putting in proper delimiters and everything. And you can see that I can format the same number with different locales using a different format. So you have it in Arabic and Bangla, and you can even format a number as a currency. So over here you format 100 Japanese yen. Of course, the first syntax is more efficient for formatting multiple numbers with the same settings, while the latter is more efficient for formatting one or two numbers using different locales, as you notice. Moving on to date and time formatting, you can also create a date time format. Like here, I've created one with the locale Spanish as spoken in Mexico, and I can format the current date with it. And I can even use this, as mentioned previously, we can use the toLocale date string and toLocale time string, similar to the last one. And over here you can see the date in French and the time in Chinese, and you can provide a lot of granular options like the exact length of the weekday and the month, and as you can see, it outputs the exact format as you expected. Relative time formatting is a really important use case for a lot of especially web applications. You can create a relative time format object with a specific style. So here I created one with narrow, and you can say things like, oh, in 3/4 or 1 day ago. And given your locale, well, you can have something smaller like the Spanish locale, and then 2 days would then become pasado mañana instead of in 2 days, which is the format that is used in Spanish. Collation is a really important use case, especially if you do a lot of computations on strings. So here you can see, you can observably demonstrate the difference between German and Swedish locales by comparing the uh, accented A with Z, and you can see that it's -1 for German and +1 for Swedish. And you can also see that AA is less than 1 for as compared to AB for English, but the other way around for Danish, for example. Tool rules is also a really interesting use case. It's certainly a bit more low level as compared to the others, but if you have a locale that is other than English, especially because English has just two plural rules, as you might have noticed. So for example, here I have Russian, and then I can pass in any numbers I want, like 1, 3, and 6, and it will give me the plural rules for those. So 1 is 1 in Russian, 3 is a few, and 6 is many. So there's a bunch of locales, as I demonstrated here. Russian and, for example, Arabic have different plural rules than English, which is just 2, 1, and other. And this is a really useful object for such cases.
Thank you, Ujwal. Now I'm going to proceed here with a live demo of some of these features. So to start this live demo, I'm going to open up the DevTools. I'm using Chrome, but you can use whatever browser you like. And I'll go ahead and print a version by doing navigator.userAgent, just so I can see exactly what version of the browser I'm using. In this case, it looks like I'm using Chrome 85. Okay, so I'm going to start by showing a few example features. One common thing you might want to do is create a new relative time format, Intl.RelativeTimeFormat. For example, in locale RO, Romanian, we can see what happens when we format, for example, 5 years, and we get the relative time format for Romanian. Um, Another thing you can do is use the other form of Intl, which is the toLocale string. Um, when you're using on a date, you can pick between toLocale date string or toLocale time string. So if I call toLocale date string, it prints out the current date in my current locale. If I want to specify a locale, I can put it as an argument here. For example, ZH for Chinese. Um, if I want to specify some Unicode keywords, like for example, I can specify the UCA Chinese calendar using the Unicode keyword. It shows me the date in the Chinese calendar. Now, if you're not familiar with the Chinese calendar, you might be wondering, well, why does it show the Gregorian year 2020 even though it's showing a Chinese calendar? We can find this out by using the format to parts function. To do this, I need to do new Intl.DateTimeFormat. I can use the same locale as before. And then I'd call format to parts, new date, and then I can introspect exactly what all the different parts are. In this case, the 2020 is a field type related year. And then the rest of the fields are literal, month, and day as shown here. So that's how format to parts works. It lets you introspect. Another thing you can do is, for example, format this to Arabic. Let's actually do a number into Arabic. Let's do a number into Arabic, and it formats it using the um, Latin numbering system, even though it's Arabic. This is not a decision made by the 402, that's made by CLDR, but if you specify a more specific type of Arabic like AREG, it gives you the string using the Arabic numbering system. Now, another way to opt into the Arabic numbering system is to use an option in the options bag, which is the second argument of to_locale string, numbering system Arab, which also opts you in to use that numbering system. You can also specify it in the locale string like I did with the Chinese calendar above. Now, when you're passing arguments to these functions, you don't have to pass just a single locale by itself. Oftentimes, it's better practice to pass a list of locales, and then it resolves the fallbacks appropriately. So for example, if I look at my navigator.languages, you can see that my browser is set up with two languages here. And this is the parameter that gets passed automatically if I don't pass any other argument for locale when I'm in the browser. And it's good practice to pass a fallback list. So if the first locale in the list is not supported, it just falls back to the next one. This is especially important on the server when the environment locale is not useful for doing formatting of user requests. You should get the list of languages from the accepts languages header and then pass it in as the first argument of to_locale string.
Now it's time to talk about proposals nearing completion. And from nearing completion, I mean that these proposals are implemented in at least one major browsing engine. So first off, we have Intl.ListFormat. What do you do if you have a list like this and you want to format that in a locale aware manner? You can use the new list format constructor and pass in the locale. So here it's English US and the type of the list that you are using. So here I have conjunction, and that would format it out for you quite nicely. And the same can be done, for example, for a list of things in Spanish, and then you can create a list format corresponding to that. And this time we have disjunction, and it would appropriately also format this. This proposal has been shipped in Firefox 78 and Chrome 72, and Safari support is still pending. Next up, we have date style, time style. Now, if you remember me talking about date-time format just a few minutes ago, you remember how verbose the exact syntax for all of it was, and you needed to specify the each field separately and how you wanted them to be displayed. Now, there's a very important use case for allowing people to specify more general styles for dates and times. Let's see how that works. So you can say, new datetime format and just time style short, and that would give you this convenient format. You didn't have to uh, manually exclude a bunch of units and specify minutes and hours. It just worked for you. And the same can be done in a sort of permutation way. So you can say time style medium and date style short, and this would give you one of the possibilities, which is a medium time and a short date. This also has been shipped in Firefox and Chrome, and the implementation in Safari is still pending. Talking about units and compact notation, this is a slew of really interesting features that have landed in number format. So for example, you can now format a number and say notation compact and compact display long, and you can, instead of getting all the 1,000 separators and everything, you can get a simple 987.7 million. And you can toy around with a compact display to get something like an M or mil. What about units? You can specify the style to be unit and provide the exact unit. There's a list of units available. based on the CLDR data, and you can get the formatting based on that particular unit. And you can use something like sign display to specify exactly when to display the sign. So I put in a style %, and for any value other than 0, it would display explicitly a sign. This feature has been shipped in Firefox 78 and Chrome 77 and pending a Safari implementation. Next up, we have Intl.DisplayNames. So what DisplayNames allows you is to say, I want the display names in Chinese for regions, and then you can query the names of all the regions in Chinese. And the same can be done in English for currency. So you can say names of USD, and that would give you the US dollar. So this allows you to go through a list of currency codes, for example, and convert that to a human readable list of names. An interesting use case that we were dealing with was to use this API to and iterate over a list of IANA time zone names and print out a list of human readable time zone names. So it would go over something like America, Los Angeles, and print out something like Pacific time. Uh, or IST or Asia Kolkata and print out something like uh, India Standard Time. This has been shipped in Firefox 78 and Chrome 81 and has a Safari implementation pending. Now, Intl.Segmenter is one of the most interesting new proposals. It allows you to segment any given string in a certain locale based on a granularity. So you can have a granularity word or a sentence, and this is really helpful for iterating over strings. If you're familiar with ICU, which I think a lot of you would be, this is equivalent to break iterator. And this feature has been shipped in Chrome 87 as sort of a successor to the create break iterator class, and Firefox and Safari support is still pending. Next up, we have date ranges, and this is an interesting feature that allows you to create a datetime format as usual, but instead of calling format on a single date, it allows you to say format range and accept 2 parameters. And using this, you can format a whole range of dates instead of just a single date. This would be useful, for example, uh, for an application like Amazon, which needs to tell you that your coffee would arrive for anywhere between October 7th and 9th. This feature has been shipped in Chrome 76, and Firefox and Safari support is pending. Now that that's over with, let's talk about the active proposals, which are the fun new features that are coming soon, but which are not yet shipped in a browser, which are still being worked out. First up, we have number ranges. So you just remember date ranges from 2 slides back. This is uh, continuing in that direction and adding range support to number formats. So instead of saying uh, format in a number format, you can say format range, and that, as usual, takes 2 parameters instead of 1. So your cab application can say that the ride is going to cost you between 3 to 5 euros, and it will arrive, let's say, in 6 to 7 minutes. And to say minutes and disambiguating it from minute, you need plural rules for this. So you can select a range instead of just selecting a single value. So that's it's a stage 2 proposal, which means it's still in design phase, and the final API details are still being worked out. Next up, we have Intl.DurationFormat, which is something that I've been personally working on, and it's quite a straightforward proposal, actually. It accepts a duration, so in this case, it's 1 hour, 46 minutes, and 40 seconds, and you can pass in a locale and a style, and it would print out that duration formatted in that style and in that locale. So that's pretty simple. It's a stage 2 proposal as well. And following that, we have Intl enumeration API. This proposal would allow you to do something along the lines of this. So you can say get supported calendars, and it would print out something close to this. But this extends to things beyond just calendars. The driving use case for this was when we wanted to get the list of supported time zones on a particular environment. And this can be really useful when developing drop downs or lists of choices in applications. Next up, we have smart unit preferences. So if you remember from previously, we had unit support that is already being added to number format. And now you can sort of tweak, you can play around with that and provide the usage for a particular unit, which is a new parameter. This is really an interesting use case, and I know about it a lot because it's particularly relevant in my home country, India, where we measure distances in kilometers, but the height of a person would ideally be measured in feet and inches. Waist would be measured in inches, uh, while the area of a building would be measured in square yards. It's a uh, really interesting case in which it allows you to derive the precise unit to be used for a particular case based on what do you need to use it for. So here it automatically goes to 5 feet and 11 inches instead of saying 1.8 meters. Now, this is a stage 1 proposal, which means it's still in the research phase.
Okay, so I know a lot of you are thinking, well, I want to use some of these new upcoming features sooner before they're widely available in browsers. And your solution for that is to use a polyfill, such as the one implemented in Format.js, which is the Format.js team has been doing a phenomenal job providing polyfills for most upcoming ECMA 402 features. So you can go to formatjs.io for more information on polyfills for ECMA 402. Okay, so one question that I get a lot is, okay, there's so many great features in ECMA 402. Why don't you just expose all of ICU for C? Well, the answer is because ICU for C has so many features that we don't necessarily want to expose all those to users because they're not all relevant in the web context. So in the web context, we're focusing on features that are most relevant to users on the web, to client-side users, to client-side applications, and the things that are most useful for them include things like date and time formatting. A lot of the formatting operations are very relevant to those users. A lot of all the other features that we showed you are all very relevant. ICU for C does a whole lot of other things, like, for example, um, character set conversion that is not necessarily relevant to client-side users on the web. And exposing all of ICU for C would also be a big job in order to design bindings for all of ICU for C into JavaScript. And those bindings are not trivial to write. We spend a lot of time just evaluating the different API options. We do a lot of user research for every API we design to try to make sure that it accurately reflects the use cases. ICU for C doesn't necessarily have an API that directly reflects use cases and is easy for developers to use. So we spend a lot of time in 402 to sort of design that surface. So you can think of 402 as sort of an API surface for libraries like ICU that's optimized for ease of use on the client side. Okay, finally, I'm going to talk about future directions for ECMA 402. One future direction is message formatting. There is another talk about this at this conference. Some of the questions are, should we make an Intl message format? There's pros and cons. But the main con is that it locks the ecosystem into a single format. Hopefully, once we come to a unified Unicode message format standard, we can go ahead and move forward on Intl message format because this is one of our most top requested features. Another is a locale data provider, which will allow websites to provide their own locale data instead of using the data that's built into the browser. One question I get a lot is, well, where does the locale data come from? And the answer is it depends on the browser and it depends on the operating system. In the case of Chrome, the data comes from the version of ICU that Chrome is built with, and Chrome ships a version of ICU. However, in browsers like Safari, the version of ICU is the one that's available on the operating system. So the locale data can come from a lot of different places. It's not necessarily consistent. So by having a locale data provider that lets you specify where the data comes from, websites can, for example, add support for new locales even if they aren't supported by the environment. But then, one downside here is that it provides less consistent itinerary across the platform as a whole. So if your website has a locale data override, well, then the things that your users see might not be the same as they see on another website. The next is genders, inflections, and capitalization, and other various grammatical features. This is a very important area, and luckily we have friends at the CLDR and Unicode who are working on getting better data to support things like gender, inflections, and capitalization. So hopefully we'll be able to see some of this rolling out soon. It'll probably roll out quietly. Um, there may be options that you're able to pass in called the display context to let you trigger the correct case, the correct noun case, and other things that you need in order to create spoken language that sounds correct in all languages. And one other final um, nascent proposal is Unicode properties, which lets you, for example, take a string and break it into characters and lets you get the Unicode properties associated with those characters. The champion for this proposal is Stephen Loomis. If you're interested in this proposal, please talk to Stephen, who would be very excited to hear your input on exactly how we can design and move forward with this feature. Okay, so the last and maybe the most important slide is what we need. What do we need from you? Thank you so much for coming to this talk, but now I'm going to give you a call to action. How can you help with developing the 402 standard? One of the big things we need is documentation. We need to let other people know how to use these features. I've just told you how you can use most of ECMA 402, but we need to be able to let other people know how to do that too. So we need help with documentation and tech writing. Another thing we need help with are more professionals to join our calls and participate in the standardization process. It will help us design better libraries. There's been a lot of really major important decisions that come from IETN and localization experts who join our monthly calls. This is a collaborative process in an open standard, so please be active and participate to help make the platform even better and higher quality. Another thing we need are browser implementations, spec text, and spec tests. If you are skilled in, for example, writing these implementations in Firefox or Safari, this would be great and would really help us accelerate the speed at which we're able to roll out features to platforms. Another thing are polyfills. Format.js has done a great job with polyfills, but there's new proposals that keep coming up, and as more proposals keep coming up, the polyfills keep needing to be updated, and writing new polyfills for all the new features. So if you like writing JavaScript, this would be another great way to contribute. And finally, join our monthly teleconference as an IETN or professional. You can email this address in order to join that teleconference, and I really encourage you to do so. Thank you everyone for tuning in today. My name is Shane. My co-presenter's name is Ujwal. On the screen, you can see our contact information. You can also see the email address and website to get more involved with ECMA 402. I'd now like to open the floor for questions, as well as suggestions for directions that you think would be good for us to take in ECMA 402. Thank you.